Performance is one of those vague subjects that is often taught by example. In this section, I want to discuss some of the performance optimization strategies we took when working on the second version of the kitchen sink demo. During our debugging of the contacts demo, that is a part of the new kitchen sink demo, we noticed its performance was subpar. We assumed this was due to the implementation of get all contacts, and there is nothing to do. While debugging another issue, we noticed an anomaly during the loading of the contacts. This led to the discovery that we are loading the same resource file over and over again for every single contact in the list. Conclusion: don't assume. In the contacts portion of the demo, we have a share button for each contact. The code for constructing a share button looks like this. This seems reasonable until you realize that the constructors for SMS share, email share, and Facebook share load the icons for each of those. These icons are in a shared resource file that we load and don't properly cache. The initial workaround was to cache this resource, but a better solution was to convert this code. This way, the resource uses lazy loading as needed. This small change boosted the loading performance and is probably the general performance due to the less memory fragmentation. The lesson that we should learn every day is never assume about performance. Another performance pitfall in this same demo came during scrolling. Scrolling was janky, uneven, and smooth right after loading finished would recover after a couple of minutes. This relates to the images of the contacts. To hasten the loading of contacts, we load them all without images. We then launch a thread that iterates the contacts and loads an individual image for a contact, then sets that image to the contact and replaces the placeholder image. This performed well in the simulator, but didn't do too well even on powerful mobile phones. We assumed this wouldn't be a problem because we used util.sleep to yield CPU time, but that wasn't enough. Often when we see performance penalty, the response is move it to a separate thread. The problem is that this separate thread needs to compete for the same system resources and merge its changes back onto the EDT. When we perform something intensive, we need to make sure that the CPU isn't needed right now. We added a variable called last scroll, which updates when the user tries to scroll the screen with the current time. Then we did this within the background loading thread. This effectively sleeps when the user interacts with the UI and only loads the images if the user hasn't touched the UI in a while. Notice that we also check if the scroll changes. This allows us to notice cases like the animation of scroll winding down. All we need to do now is update the last scroll variable whenever user interaction is in place. The code above works for user touches. The code below works for general scrolling. Due to technical constraints, we can't use a lambda in this specific case. Once this was done, scrolling became smooth and filled out the entries when we were idle. We wrote this code before call serially on idle existed. I wonder if it would have worked as well for this particular use case. It's really easy to optimize in a cross-platform way. I optimized by moving stuff to a separate thread and yielding for the main thread. This would impact all platforms and provide a smoother experience all around.